This time we're going to talk about truth tables. We have already seen truth tables when we're determining when our propositional forms, the negation, conjunction, disjunction, conditional, and biconditional statements will be true. But do remember that not all of the propositions or statements that we would have are actually just as simple as these. It will be a combination further of these propositional forms. And to determine whether those statements are true or not, we have to create truth tables for those statements basing on the truth tables that define these specific propositions. And that's what we're going to do. Construct truth tables for more complicated or compound complex propositional forms. So, for this one, we are asked to construct a truth table for this specific proposition, not P or Q. And then we're asked to use the truth table to determine the value of the given statement given that P is true and Q is false. So first, let's construct a truth table. The truth table needs to consider all possible truth values of the given statement. Now, we know that P can be true or false and Q can be true or false as well. So, therefore, if we need to figure out what would be the possible truth values of P and Q for this statement, it would be true, false, and we would have to combine those. So, to further sort that out, if I will have P as true or false, then if P is true, Q can either be true or false as well. And if P is false, Q can be true or false as well. So I have 1, 2, 3, 4 situations where I would have the truth value of this entire statement. Anyway, I only have true propositional variables. And that is when P is true and false. So I will have P is true and false. I have 4. 1, 2, 3, 4. I have two ones and two zeros for P and 1010 for Q. 1010. Now, this is just a technique that I developed wherein P would always be 1100 then Q 1010 so that it's easier for us to write. Because anyway, we only have two. If we would have more propositional variables, then the number of rows which corresponds to a different situation would be given by the formula 2 raised to n, where n is n is the number of propositional variables that we have. But since we only have 2, we'll have 2 raised to 2, which is 4. So we have 4 situations wherein we can determine whether or not the entire statement is true or not. So now let's construct our table. Now, remember that we would always base it on P and Q. So the first thing to do is go inside the parentheses, which is what we usually do in math. Here we have a not P or Q. To make it easier for us to look at our table, it is recommended that we also find the truth values for each complicated or not simple propositional variable, even not P. So this is not P, and I will just base it from P. So I will have 1, but not 1 is 0, not 1 is 0, not 0 is 1, not 0 is 1. By the way, 1 here, just to remind everyone, is true, 0 is false. That is what we are using. And now, we can now do this one, the not P or Q, the truth value of that propositional form. So we're just going to base it on the column not P and the column Q. So, false or true is true, false or false is false, true or true is true, true or false is true. So these are now the possible truth values of not P or Q, basing on the other columns here. But we have to make sure that it's not not. It's the not of not P or Q that is disjuncted or is with or Q. So we have to get the not P or Q. And not 1 is 0, not 0 is 1, not 1 is 0, not 1 is 0. And then now this is what we have to disjunct with Q. So I will have not P or Q. So I would now have to compare this and this one here. So false or true is true, true or false is true, false or true is true, false or false is false. And here is now our complete truth table for the entire statement. So, just to recap what we did, we first took a look at all possible truth values of our propositional forms and not propositional forms first, but the propositional variables, and combined them so that we would know the all possible combinations of the truth values of the propositional variables. And then little by little, we went to the truth values of each propositional form available in the statement given the combinations of the truth values of the propositional variables. And now, in letter B, we are asked to determine the truth table, use this table to determine the truth value of the statement given P is true and Q is false. P is true and Q is false. So here you go. So, if statement P is given as true while statement Q is given as false, this statement would have a truth value rather that is true. And that is one example of constructing our truth table.